In this next example, we're going to learn how to solve for an interest rate inside of the compounding formula. So for this example, a woman who is now 28 years old invests $30,000 in a retirement account that is compounded monthly. What interest rate would she need to earn in order for the account to be worth $500,000 when she retires at age 65? Now, what's going to happen on this account is she's going to invest this $30,000 into this account, and she's just going to let it sit there until she is of age 65. And so this is a little bit different than most retirement accounts. Most retirement accounts, you would maybe pay into it every month by doing like a payroll deduction or something like that. So in this one, it's going to be a little bit different because she's just going to put the money in there and she's going to let it sit in there. She's not going to add to it, and she's not going to take any money out. Now, this is going to be then compounded monthly, so I want to use my general compounding formula, which is A is equal to P parentheses 1 plus R over N raised to the exponent of N times T. Let's go ahead and record these players over here and figure out what numbers I'm going to use for each of these different variables. A is what we want the account to be at the end of the investment. So she wants $500,000 or $500,000. P is the starting amount of money or the principal, and she wants to start at $30,000. The interest rate on this problem is unknown. Since this account is being compounded monthly, my value for N is going to be 12. And then the time in years the money is going to be sitting in the account will be 65 minus 28. So 37 years will have elapsed. So let's go ahead and substitute these numbers into this formula. All right, so I have my 500,000 is equal to 30,000. 1 plus little r is unknown, n is 12, raised to the exponent of 12 times 37. Ultimately, I want to solve this equation for little r. Now I'm going to clean up this exponent on this next step, but the other thing is if I want to solve this for little r is I don't need this factor of this 30,000 to be over here. So I can go ahead and I can divide both sides by that to get it out of off this right hand side. Okay, so I'm going to do two things at once. First off, I'm going to remove that factor from this side. And then cleaning up this side, we'll actually find that this does not divide nicely, but I can at least get rid of all of those trailing zeros. And I'm going to clean up this exponent. So over here on the left, I would have 50/3 is equal to, and on this side I have 1 plus r divided by 12, and then 12 times 37 is 444. Alright, so the next thing I'm going to have to do is I'm going to have to get this r out of this parentheses expression. Now this expression is being dictated by this exponent up here that's attached to it, so I'm going to have to undo that exponent. So let's review back from algebra. How did we undo exponents? So let's say, for instance, I wanted you to solve this equation, and I had, for instance, x squared is equal to 4. And I wanted you to undo this exponent. How would we undo that? Well, to undo squaring, we would square root both sides. Now on these ones, you had to deal with the fact that when you introduced the square root, you would get your answers as being positive or negative too. You would have to introduce this plus or minus when you had these even exponents. We won't have to worry about the minuses in these types of problems because these are always going to be problem applications, so negative numbers aren't going to make sense. Okay, so we would undo these squaring with square rooting. What if it was a problem that was about cubing? So what if I, for instance, had the equation x cubed is equal to 8? How did we undo cubing? Well, you would cube root both sides, right? So we would put this little 3 right here. That would be what would be called the index of the radical. So you would undo cubing by cube rooting, and then you would solve for your variable. Coming back up to here to this problem then, how am I going to undo raising something to the 444th power? We're going to have to take the 444th root of both sides. So here's what this would look like on paper. Now I'm going to go ahead and rewrite this line and then leave myself some room to introduce that radical. So I would have 1 plus r over 12 raised to the 444th power. and we are going to apply a 444th root to both sides. Now this 444th root will cancel this 444th exponent up here, and then I'll just have this piece that'll fall out. Now we're going to talk about in a moment how to do all that in your calculator, but for right now we're just going to keep track of what's going on, what we would have to actually enter in our calculator. Alright, so now I've introduced something that's going to undo that exponent, so then coming back up here, I would have the 444th root, and underneath that radical would be 50/3. Now this, again, this number right here is called the index. It sits right here on the shelf of the radical. Okay, so it's not written out in front, it's right here on this kind of this checkmark piece. So the 444th root of 50/3 is equal to 1 plus r divided by 12. So I'm still trying to solve this for r, so the next thing I'm going to do is I'm going to subtract 1 from both sides. Okay, so that'll effectively move that off of this side. So I will have the 444th root of 50/3, and then minus 1, which is going to be outside of this whole radical thing, is equal to r divided by 12. And then finally, the last thing I'm going to do is undo the dividing by 12 by multiplying by 12. On this side, because I have more than one term over here, I'm going to have to multiply that entire side by 12. So then those guys then will cancel. So then I would get r is equal to 12 times the 444th root of 50/3 minus 1. Alright, so that's what we're going to have to enter into our calculator. Okay, so at least now I know what I would have to enter, so now I'm going to go to the calculator and we're going to key in this entire expression all at once. Now I'm going to be using my graphing calculator, but even if you have a scientific calculator, it'll still have the same buttons that I'll be using, but maybe in a slightly different location. Now first off, I'm going to key in the 12, and then I'm going to key in those parentheses. Now the next thing I want to enter is that 444th root of 50/3. Now right here you might see this radical symbol, but this one is for square rooting. So we don't want a square root, we want a 444th root. So the first thing we're going to do is we actually key in our index. So I want my index to be 444. And then I'm going to go inside math. Okay, and inside this math menu, option number 5, this is your generic radical. So notice it has an x and then your radical symbol. So what it's going to do there is whatever number we had just keyed in, that's the number it's going to use as the index for that radical. Now you can either arrow down until you hit this option to select it, or because it's option 5 on this graphing calculator, I just could have hit the number 5 to grab it. Alright, so now this number will be the index right here, and then underneath this radical symbol, I need 50/3. Now, this calculator software, it did not introduce a parentheses. Some calculator softwares actually will start the radical with a parentheses. I need to type it in though, because I need my radical to be 50, or to have this number underneath, which is called the radicand. I need it to be 50/3. So because my calculator did not introduce the parentheses, I had to introduce them so that this entire number is underneath the radical symbol. Okay, so this problem was a little bit more complicated, not even just because of the index, but also because I have a fraction that I want underneath the radical. If you just had a single number that you wanted underneath there, you could have just keyed in the single number and you didn't necessarily need parentheses. Parentheses are always a good idea though. It just helps you to be able to visualize where your radical starts and stops. Okay, so I've closed the parentheses, which means I'm ending my radical, so all of this was needed for the 444th root of 50/3, and then it was minus 1, and then close the parentheses for that entire parenthesed expression right here. So I would hit enter, and then I'm getting 0.07627, 0.07627 ... Alright, so then this interest rate, moving this decimal over 2 spots, it would be 7 point, and then I could round to, you know, however many decimal places I needed my percent to be. So maybe I'll take this out to 2 decimal places. So this would be 7.63%, and then APR.